Now let's take a look at some special cases with combinations of functions. Given that f of x equals x squared minus 9 and g of x equals 2x plus 1, find the following. Well, by definition, f times g of 3, which is what we're first tasked with finding, is f of 3 times g of 3. Well, if we find f of 3, that would be 3 squared minus 9, which is actually 0. So 0 times, and then g of 3 would be 2 times 3 plus 1, which would be 6. That would be 7. So 0 times 7, which is 0. So with a product, if either function is 0, then the product is 0. That's how real numbers work. Now, part B says f divided by g of negative 1/2. Well, this would be f of negative 1/2 divided by g of negative 1/2. F of negative 1/2 would be 1/2 squared, or negative 1/2 squared, minus 9, divided by 2 times negative 1/2 plus 1. Now, I'm going to evaluate the denominator first, because this is negative 1 plus 1 is 0. The denominator cannot be 0, so as long as the numerator is not 0, in fact, even if the numerator is 0 as well, this is going to be undefined. So f divided by g of negative 1/2 is undefined. That's why this is a special case. For our next example, we have given that h of x equals x plus 4 and g of x equals the square root of x minus 1, find each of the following. H times g of negative 4. It's h of negative 4 times g of negative 4. Well, h of negative 4 is 0. So that's 0 times g of negative 4. Well, if I plug negative 4 into there, square root of negative 4 minus 1, which is the square root of negative 5. Well, that's undefined in and of itself. So we have, I'm just going to write it like this, 0 times the square root of negative 5. And that is going to be undefined as well, because the second term is undefined. And for our last example, h divided by g of 1. Well, this would be h of 1 divided by g of 1. H of 1 is 1 plus 4, or 5. G of 1 would be the square root of 1 minus 1. I'm just going to write this here, which would be the square root of 0, which is 0. So 5 divided by 0, which is undefined. So we have to be mindful, be aware of the domain restrictions for both functions as we evaluate them, depending on if we're looking at a product or a quotient.